you see the text here clear? Is it too small or it's fine? Great. Thank you for the feedback. Okay. So now this is the topology I have built in GNS3. If you haven't used GNS3 before, it's very similar with packet tracer, but I would say it's the command is all the same. I'm using this router is a Cisco iOS image, so exactly the same command how you operate. So I have two. One router acting as a DHCP server. Okay, I have configured this correctly before with what is the DHCP pool I have configured, and the DNS server and the default gateway I have configured all of it. So if you are not clear about how to configure DHCP server, you can refer to our previous slides and also in the lecture notes. I have a switch and a router. This router, I'm using it as a DHCP client. So it's a normal one. It's a good one. It's trusted one. So it will get his IPv4 address from this DHCP server. And this is a Ubuntu. So this is connected to my Ubuntu here. This is running inside of my virtual box. Okay. So what I will do is I will launch the attack. So this Ubuntu will be our attacker, and try to attack this DHCP server. How? So before the attack, let's have a look. What is the IP address allocation is going on. So let's first go into, so this is the R1, the DHCP server. Let's look at DHCP bounding. So you can see the DHCP server has already created two IP address, 21 and 22. 21 is the IP of R2, 22 the IP for this Ubuntu, okay? And now let's switch to the our Ubuntu here. Let's have a look. ifconfig. So you can see I have in my Ubuntu I have three network interface, three adapter. The EMP0S8 has the address of this subnet. So this is allocated from my DHCP server in the GNS3. Okay. Okay, so let's look at this R2. This is our normal, it's our trusted DHCP client. So IP int brief. You can see the IP address is 21. It's allocated by DHCP. Okay, its status is up. So far everything is good. Okay, and we would be also interested to compare what is difference between before attack and after attack. So we will be interested to see this may be also very useful in the future if you're doing your final year project. We look at the CPU utilization rate in the DHCP server, because if attack happened, the sessions, there are many packets discover frame flooded into DHCP server. So the server will be running fully and overloaded. So let's see the CPU rate at this moment. So it's pretty good. The utilization for it's only like 2%. It's very low. So let's remember this for this moment and see what happened later on. And okay, another good thing is before the attack, let's try to ping from this trusted router to the this is the remote one. Okay, Ubuntu. Let's try to ping if it works. It's 22. So you can see the pin successful, and you can pin from the Ubuntu to this router 2 as well. Okay. Now let's start the attack. So first I need to go to the root mode. I'm going to start my Yersinia. So this is the open source tool I have installed on my Ubuntu. To install it, it's very easy. Just using one command, sudo apt to install, you can have it quickly. And let's start the graphic user interface. Oh, sorry, it's not into my Yersinia. So this is the graphic user test of Yersinia. Okay, so you can see there is a lot of different attack you can have: CDP, DHCP, and DTP, STP. So I will start. First, I need to configure which interface this Ubuntu started the attack from. So remember the interface is this one. So we will go to from this. And now let's launch the attack. We try DHCP. So there are different type. We will try this first for our first demo, sending discover packet. So what this attack do, which means that Ubuntu will keep sending a lot of discover packet to the DHCP server. Said, okay, can you please give me a IP, give me an IP, give me an IP. So I want more and more. So the DHCP server will processing and will create lots of IPv4 address for the response. At this moment, because this Ubuntu is not identified, it's not authorized, authenticate. So DHCP server has no idea is this a good one or it's a bad one. It's an attacker. Okay, so let's start. Okay, you can see this here. It's the process. It is these are the discovery request message. Now let's back to the DHCP server, which is R1, to see what is the CPU rate. So surprisingly, it's 96%, which means it's overloaded by this discover message. Okay, so this is you can indicate, okay, the attack is happening right now. Okay. Okay, so I'm going to let's have this attack going for a while. Okay, now I'm going to stop this to save my memory resource. And let's go back to the DHCP server again. What I would do is show IP DHCP binding. So I'm wondering how many does this DHCP server has created many IP for this attacker? Let's see. It may take a while. I can hear the fan on my laptop is running really fast. The attack is consuming a lot of the CPU resource of my laptop as well. Okay, still waiting. Okay, I'll try again. Apparently, the resource is being, you see the CPU rate was 96%. So the response currently is really, really slow. So it is, the command here is in the queue. So it had to wait until the CPU is released and now start to take this command. Is it still processing the discover message? Not now, because I have stopped attack. So which means I have stopped sending the DHCP discover message. Okay, try again. Come on, it's very okay. Good. You can see. So at the beginning, before the attack, we only have 2 IP created, but now how many we have? A lot. And these are from nowhere. It's just a virtual request. It's not for real machine, but the DHCP server has created so many IP. Okay, so which means the DHCP server will be full loaded. And the bad thing is, there is always a limit for the number of IP address can be given. So if the space is taken up, is used up, if there is a real good client join and he requests an IP, and unfortunately there will be no more IP for the new joined device, right? So this is the purpose. To what extent DHCP server can affect? Yes, Mahmoud, this is what I just explained. For example, first, the DHCP server will be fully loaded, and DHCP server cannot do anything else because it has to processing this frequently incoming message. So this is one bad thing. Okay, to overload the DHCP server. Second, because DHCP server will use up all of its IPv4 address in the address pool. Okay, remember there is address pool. The address pool is limited. So when the new client join the network and this new client requests a new IP from DHCP server, so unfortunately he will not get IP because there's no available IP address in the pool. Does it make sense, Mahmoud? Yes, great. So you can see this is why it's called starvation. So when new clients join, okay, I'm starving to have IP, but there's no more IP available. So this is called starvation attack. Okay, it's a very good name actually. Okay, so next.
Chenkawi, for the security, the information security triad. So this attack only affects the availability of the service, doesn't it? So not the integrity and not the confidentiality as well.
No. You are said. Yeah, your point is correct. It's only for the resource. Cool. To take up the DHCP, the IP address pool, to overload the CPU and the memory of the DHCP server, to overload the resource.
Cool. Right.
Okay. Yeah, no problem. It doesn't steal any privacy or sensitive data. It just overload resource. This is a very original, a very simple attack, right? But it works. It make your server down. Okay, you cannot do any normal stuff. Okay, now let's try the second demo. I will. Okay. Give me a second. Okay, now let's look at a second type of DHCP attack. That we can create a rogue DHCP server, which means because the client may have no idea, okay, if this DHCP server is a trusted one, it's a good one. So what if our Ubuntu acting as a rogue server, DHCP server, and if the client trying to request an IP, so this bad DHCP server can acting as a real one and give an IP. So this is more danger, because in this way, this rogue DHCP server will take in control of everything for this client. Okay, so let's have a look at how to do this. We continue use this topology, and now when we do attack, okay, creating. So Yersinia is doing a very good job here, creating DHCP rogue server. Okay, and we need to configure it. So server ID is the IP address for the DHCP server. So I'm randomly giving. Okay, so this is the IP address pool. Okay, we start from, let's see, here, lease time give 500 seconds, renew time 400, subnet default router, default gateway, DNS, give it the same. Okay, domain random, I give myattack.com. Okay, this is the domain. Okay, so I'm starting the attack. Okay, it's starting already. So at this moment, there is a rogue DHCP server running at the Ubuntu. Okay, so if I drag in a new device, I'm dragging a router here, and connecting to here. Okay, going to start this. So what I will do is I'm a new device, okay, and I want to request, because can someone give me an IP? So using DHCP config no IP routing interface IP address DHCP. So this command means we'll sending DHCP. R3 will sending out DHCP discovery, said, can anyone give me an IP address? Okay, no shot. Okay, let's wait a second. Okay, so after a while, you can see here there is a request and an offer is given from the Ubuntu. So let's see if IP is given to this. Sorry. So IP int. You can see, okay, the new device got IP 10, which is in danger, because this IP is given from this Yersinia. It's from the rogue server. It's not from this DHCP server. So it's the R3 will be completely under control of this, right? So this is a very, very dangerous attack for DHCP. As Mohammed said, it's not only about the resource. It's about I have control over you. I can steal your security. Okay, so this is more in danger. Okay, so this is the demo. Any questions? If no more, I will continue with the slides. Okay, I'm going to share.